Question 1. In the context of energy auditing, Mr. Thompson notices that a commercial building's air handling unit cycles frequently, leading to inconsistent temperatures across zones. He suspects the issue is related to airflow distribution. What should Mr. Thompson investigate first to identify the root cause? A. Check the building envelope insulation. B. Measure the duct static pressure and verify the damper positions. C. Inspect the refrigerant charge in the condenser unit. D. Adjust the thermostat deadband settings. Answer. Correct answer. B. Explanation. Frequent cycling and inconsistent zone temperatures typically indicate airflow imbalance rather than envelope or refrigerant issues. Measuring duct static pressure and verifying damper positions allows the auditor to determine if airflow is restricted, uneven, or improperly balanced. The building envelope would affect overall load but not cycling frequency in individual zones. Refrigerant charge issues primarily in cooling capacity, not airflow distribution. Thermostat adjustments without addressing mechanical airflow issues cannot correct imbalance. Question 2. Which of the following best describes why Mr. Lopez should consider using a psychrometric chart during an energy assessment of a multi-zone office building? A. To size the HVAC ductwork for minimal pressure loss. B. To evaluate temperature and humidity relationships and optimize comfort conditions. C. To determine refrigerant pressures in the expansion device. D. To calculate the building's envelope heat loss. Answer. Correct answer. C. Explanation. A psychrometric chart is a fundamental tool for analyzing air properties such as dry bulb temperature, wet bulb temperature, enthalpy, and humidity ratios. By plotting these, auditors can understand moisture removal, latent loads, and mixing of air streams. This allows for optimizing comfort and energy efficiency by ensuring systems meet both sensible and latent load demands. Duct sizing and envelope heat calculations are separate procedures and not directly derived from psychrometrics. Refrigerant pressures can be correlated indirectly but are not the primary psychrometric application. Question 3. Based on the information from a recent energy assessment, Patel observes that a rooftop unit shows high return air temperatures but low condenser temperatures. Which action should she prioritize? A. Inspect the evaporator coil and airflow for blockages or fouling. B. Increase the outdoor air intake volume. C. Recalibrate the thermostats in all zones. D. Adjust the fan speed on the condenser motor. Answer. Correct answer. A. Explanation. High return air temperatures with low condenser temperatures often indicate insufficient heat transfer at the evaporator due to blockages, dirt accumulation, or airflow restrictions. This reduces cooling efficiency and may cause the unit to operate longer cycles. Increasing outdoor air intake or recalibrating thermostats does not address the root issue of airflow obstruction. Adjusting condenser fan speed alone compensate for evaporator side inefficiencies and may reduce overall system performance. Question 4. During an energy audit, Mr. Chen notices that the building's variable air volume (VAV) system frequently exceeds design flow in certain zones, causing noise and comfort complaints. What is the most effective first step to resolve this? A. Inspect and reset the VAV box minimum and maximum airflow set points. B. Replace all duct insulation to prevent vibration. C. Increase the cooling capacity of the rooftop unit. D. Adjust the thermostat set points to reduce occupant complaints. Answer. Correct answer. D. Explanation. VAV boxes often exceed design flow if minimum and maximum airflow set points are improperly configured or control signals are misinterpreted. Auditors should first check and reset these set points to match design intent. Replacing duct insulation or increasing system capacity does not resolve control-related overflows. Adjusting thermostat set points can temporarily reduce occupant complaints but does not correct airflow distribution, which is the underlying cause of noise and comfort issues. Question 5. Given the circumstances, Rivero is assessing a hydronic heating system in an older office building. She notes uneven heating across floors and suspects poor pump performance. Which analysis should she perform first? A. Conduct a life cycle cost analysis of replacing the pumps. B. Measure flow rates through each terminal unit and compare with design values. C. Verify the thermostat calibration across all zones. D. Inspect the building envelope for air leaks. Answer. Correct answer. See explanation. Uneven heating in hydronic systems often results from mismatched flow distribution or pump inefficiencies. Measuring flow rates through each terminal unit allows the assessor to identify imbalances or partially blocked circuits. Lifecycle cost analysis is a subsequent step after confirming operational deficiencies. Thermostat calibration or building envelope inspection may highlight secondary issues, but do not address flow irregularities causing uneven heating. Question 6. Considering the evidence, Assessor is evaluating the impact of retrofitting a commercial building with demand-controlled ventilation (DCV). Which metric should he analyze to determine if the retrofit is energy efficient? A. Carbon dioxide levels and variable fan energy savings. B. Thermostat set points throughout the building. C. Refrigerant type used in the existing chillers. D. Duct insulation thickness in all plenums. Answer. Correct answer. A. Explanation. DCV optimizes ventilation by modulating airflow based on occupancy, often tracked using COS sensors. Energy efficiency is realized through reduced fan operation and minimized overventilation. Thermostat set points influence thermal comfort but not directly DCV efficiency. Refrigerant types and duct insulation primarily affect cooling or heating efficiency but do not quantify ventilation energy savings, making CO levels and fan energy consumption the most relevant metrics. Question 7. Through careful analysis of a building's BAS data, Gordon observes frequent short-cycling of the compressors in rooftop unit during low load periods. What underlying principle explains why this is inefficient? A. Short cycling reduces the overall lifespan of compressors and increases energy consumption. B. Short cycling improves zone temperature uniformity during low load. C. Short cycling lowers the building's humidity levels effectively. D. Short cycling reduces duct static pressure and fan energy. Answer. Correct answer. C. Explanation. Short cycling occurs when compressors start and stop frequently due to oversized equipment or improper control sequences. This leads to energy inefficiency, wear and tear on components, and inadequate dehumidification since the system does not run long enough to remove latent loads. Although it may cause temporary comfort relief, it does not improve humidity control. Reducing duct static pressure or minor variations is unrelated to the root inefficiency caused by short cycling. Question 8. Under the assumption that the building's rooftop unit is delivering conditioned air with higher than expected humidity levels, what should Mr. Alvarez evaluate first to diagnose the issue? A. Evaporator core cleanliness, airflow rate, and proper dehumidification sequencing. B. Thermostat set points in occupied zones. C. Fan motor amperage compared to nameplate rating. D. Outdoor air economizer damper position. Answer. Correct answer. B. Explanation. Excess indoor humidity typically results from inadequate latent load handling. Evaluating evaporator core cleanliness and airflow ensures sufficient surface contact for moisture removal. Dehumidification sequencing and control logic ensures proper operation during cooling cycles. Thermostat set points do not directly influence latent load handling. Fan motor amperage and economizer position indirectly affect airflow but are not primary contributors to inadequate humidity control. Question 9. While examining the consequences of installing a high-efficiency chiller in an existing building, Kim notices reduced energy consumption but increased first cost payback period. Which concept should guide her recommendation? A. Life cycle cost analysis to weigh initial investment against long-term savings. B. Checking refrigerant charge accuracy for system efficiency. C. Evaluating fan curves for airflow optimization. D. Inspecting duct leakage for immediate comfort improvement. Answer. Correct answer. D. Explanation. Life cycle cost analysis provides a structured approach to evaluating total cost of ownership, including initial capital, maintenance, and energy savings. Reduced energy consumption may not justify high upfront costs unless long-term operational savings offset the payback period. Refrigerant charge and fan curves affect immediate system performance but do not fully capture economic feasibility. Leakage inspections are secondary and do not inform strategic financial decisions for high-efficiency equipment retrofits. Question 10. The underlying principle of energy recovery ventilators ERVs is often misunderstood during an assessment as to why it evaluates. In building with high latent loads, what should he check to ensure proper ERV operation? A. Verify heat and moisture exchange effectiveness and proper airflow balancing. B. Inspect refrigerant pressures in the existing rooftop unit. C. Recalculate building envelope heat gains. D. Measure individual zone thermostat differentials. Answer. Correct answer. A. Explanation. ERVs recover both sensible and latent energy from exhaust air streams. Their performance depends on the efficiency of heat and moisture transfer and proper balancing of supply and exhaust airflow. Misbalanced or poorly maintained ERVs can lead to inadequate dehumidification or increased energy use. Refrigerant pressures, envelope gains, and zone differentials are indirectly related to overall energy use but directly assess ERV performance. Question 11. From a practical standpoint, Mr. Harrison is auditing an older office building where occupants report some zones are overly dry while others feel humid. The building uses a central AHU with variable speed fans. What should Mr. Harrison investigate first? A. Inspect the variable speed fan control and airflow distribution. B. Measure refrigerant subcooling in the chiller. C. Adjust thermostat set points to reduce humidity complaints. D. Evaluate insulation levels in exterior walls. Answer. Correct answer. A. Explanation. Uneven humidity across zones often stems from imbalanced airflow rather than thermostat settings or envelope issues. Variable speed fans control air delivery and affect both sensible and latent loads. Inspecting fan control and airflow distribution helps identify improper valve responses or duct blockages. Refrigerant subcooling only impacts cooling efficiency, not humidity distribution. Adjusting thermostat settings temporarily affects comfort but does not resolve airflow-induced latent load inconsistencies. Wall insulation influences heat gain, but not direct moisture control. Question 12. While examining the consequences of installing an ES system in a multi-story commercial building, Lewis notices frequent simultaneous heating and cooling in adjacent zones. Which concept should she focus on to optimize system efficiency? A. Verify individual indoor unit control logic and proper zoning. B. Increase the chiller water temperature set point. C. Recalibrate thermostats for each zone. D. Inspect the outdoor unit fan speed. Answer. Correct answer. D. Explanation. Simultaneous heating and cooling in ERF systems typically results from control logic conflicts or improper zoning design. Assessing indoor unit control sequences ensures that the system's heat recovery capabilities are correctly utilized. Adjusting chiller temperature or thermostats alone does not address the fundamental control issue. Outdoor unit fan speed influences refrigerant flow dynamics, secondary to indoor unit control and zoning coordination for efficiency. Proper sequencing prevents energy waste and improves occupant comfort. Question 13. Given the circumstances, Mr. O'Connor is evaluating energy efficiency in building with multiple air-cooled chillers. Data shows that one chiller frequently operates at partial load while others remain idle. What is the most conceptually sound action to improve efficiency? A. Implement lead lag sequencing to balance loads across all chillers. B. Increase refrigerant charge in the partially loaded chiller. C. Reprogram thermostats for tighter temperature control. D. Clean the condenser coils of the idle chillers. Answer. Correct answer. A. Explanation. Chiller efficiency is highest at optimal load-in. Partial load operation of a single chiller while others remain idle wastes energy and reduces equipment lifespan. Lead lag sequencing rotates chillers to distribute load and maintain each unit closer to its design efficiency, improving overall system energy performance. Increasing refrigerant or cleaning coils affects only single unit performance and thermostat. Reprogramming influences comfort but does not address systemic load distribution inefficiencies. Question 14. In light of recent developments, Martinez is auditing a building with an ERV. She finds that the unit transfers sensible heat effectively, but the indoor relative humidity remains high. What should she check first? A. Moisture transfer core condition and airflow balance. B. Supply air temperature set points in the zones. C. Outdoor air economizer damper positions. D. Thermostat calibration for each zone. Answer. Correct answer. B. Explanation. Herbs rely on both sensible and latent energy transfer to control temperature and humidity. If humidity remains high despite effective sensible heat exchange, the moisture transfer capability may be compromised due to a fouled core or incorrect airflow balancing. While supply air temperature affects comfort, it does not correct latent load issues. Economizer dampers and thermostat calibration influence energy or comfort but do not address insufficient moisture recovery in the ERV itself. Question 15. To determine whether a building's geothermal heat pump is performing optimally, Kim gathers data showing minimal temperature difference across the ground loop. Which step best addresses the issue? A. Verify loop flow rates and check for ground loop fouling or heat transfer inefficiencies. B. Adjust indoor thermostat deadband to increase comfort. C. Inspect ductwork for leaks. D. Increase compressor speed of the heat pump. Answer. Correct answer. C. Explanation. Ground loop temperature uniformity is crucial for geothermal heat pump efficiency. Low temperature differences suggest either insufficient flow or fouling in the loop, which reduces heat transfer. Inspecting and correcting these ensures the system can meet heating and cooling demands efficiently. Adjusting thermostats or increasing compressor speed does not address the fundamental loop performance and duct leaks in distribution rather than source side efficiency. Question 16. Through the lens of energy auditing, Mr. Daniels observes that VAV systems terminal units fail to maintain minimum airflow during low load periods. Which principle explains why addressing this is critical? A. Maintaining minimum airflow prevents zone stagnation and ensures ventilation standards are met. B. Increasing thermostat set points reduces system cycling. C. Adjusting duct insulation minimizes static pressure losses. D. Recharging the refrigerant improves airflow. Answer. Correct answer. A. Explanation. Minimum airflow ensures that each zone receives adequate ventilation, preventing air stagnation and maintaining IAC. Failing to maintain this minimum compromises both comfort and code compliance. Thermostat adjustments do not guarantee ventilation. Duct insulation affects static pressure but does not resolve control deficiencies. Refrigerant charge impacts cooling but does not control airflow delivery in VAV terminals. Question 17. Considering the evidence, White is evaluating the performance of a building's fan coil units in high-rise. She notices some zones are overcooled while others are undercooled despite correct thermostat settings. What is the most appropriate investigative approach? A. Inspect hydronic flow balancing and coil valve operations. B. Recalibrate all thermostats. C. Increase fan speed for all units. D. Add insulation to the chilled water pipes. Answer. Correct answer. D. Explanation. Uneven cooling often results from improper hydronic balancing or malfunctioning coil valves, which affects flow distribution to each fan coil unit. Inspecting and adjusting these ensures each zone receives the intended thermal load. Recalibrating thermostats affects control signals, but not the physical flow. Increasing fan speed does not resolve uneven hydronic distribution, and pipe insulation influences and losses, not the immediate problem of flow imbalance. Question 18. When faced with a building exhibiting high indoor humidity and frequent rooftop unit cycling, Mr. Patel is asked to recommend a solution. What approach aligns with energy-efficient design principles? A. Adjust cooling coil control sequences to optimize latent load handling. B. Reduce thermostat set points to increase cooling. C. Increase outdoor air intake to improve air changes. D. Replace fan motors with higher horsepower units. Answer. Correct answer. B. Explanation. Optimizing latent load handling through proper coil sequencing ensures dehumidification without excessive energy consumption. Reducing thermostat set points increases cooling demand but may not correct moisture removal effectively. Increasing outdoor air can worsen humidity problems if not properly dehumidified. Replacing fan motors with higher horsepower increases energy use unnecessarily and does not underlying latent load management. Question 19. Based on the information from recent BAS data, Johnson notices that a building's AHU frequently operates below design airflow during occupied hours. What is the best first step to correct this? A. Measure and adjust fan speed to meet design airflow requirements. B. Inspect the refrigerant charge in the chiller. C. Increase thermostat deadband to reduce cycling. D. Evaluate the building envelope for leakage. Answer. Correct answer, C. Explanation. Operating below design airflow during occupied periods can reduce both thermal comfort and ventilation compliance. Measuring and adjusting fan speed ensures the system delivers proper supply. Refrigerant charge affects cooling performance but not airflow directly. Adjusting thermostat deadband or envelope leakage may indirectly influence system load but does not correct the primary airflow deficiency, which is through mechanical and control adjustments. Question 20. While analyzing the merits of retrocommissioning, Mr. Evans finds that several rooftop units have oversized compressors causing short cycling. What concept should guide his recommendation for energy efficiency improvement? A. Implement control strategies that stage or modulate compressors to match load. B. Replace duct insulation to reduce energy loss. C. Adjust thermostat set points in occupied zones. D. Increase outdoor air intake to improve ventilation. Answer. Correct answer, A. Explanation. Oversized compressors short cycle, wasting energy and reducing lifespan. Staging or modulating compressors ensures equipment operates closer to design load, optimizing energy use and maintaining comfort. Duct insulation, thermostat adjustments, or increased outdoor air intake do not directly address compressor load matching and fail to correct the fundamental energy inefficiency caused by short cycling. Question 21. When evaluating the merits of retrofitting a building with a high-efficiency variable speed pump, Mr. Scott notices fluctuating hydronic temperatures at terminal units. What is the most appropriate first step to ensure energy-efficient performance? A. Verify pump speed control and check system pressure differential. B. Recalculate heating and cooling loads for the building envelope. C. Inspect thermostat calibration across all zones. D. Increase the refrigerant charge in the chiller. Answer. Correct answer, A. Explanation. Variable speed pumps adjust flow based on system demand to reduce energy consumption. Fluctuating hydronic temperatures indicate potential control issues or incorrect pressure differential settings. Verifying speed control and system pressure ensures the pump delivers the required flow efficiently. Load recalculations affect design sizing but not current operation. Thermostat calibration influences comfort feed but does not correct hydraulic imbalance. Refrigerant charge is unrelated to hydronic distribution. Question 22. In what ways can Thompson optimize energy recovery in a building that experiences high latent loads during summer months? A. Ensure airflow balance and maintain clean heat and moisture exchange cores. B. Adjust thermostat set points to lower indoor humidity. C. Increase the refrigerant charge to improve cool performance. Answer. Correct answer, B. Explanation. Latent load handling is critical for indoor comfort and energy efficiency. Proper ERV operation depends on balanced airflow and clean cores to facilitate heat and moisture transfer. Adjusting thermostat set points affects comfort but does not directly enhance latent energy recovery. Increasing refrigerant charge improves cooling capacity but may not address moisture removal. Duct insulation reduces thermal but does not correct ERV performance. Question 23. During the process of auditing a high-rise building, Mr. Patel observes simultaneous heating and cooling in multiple zones served by a system. What should he evaluate first to resolve energy inefficiency? A. Review indoor unit control logic and zoning coordination. B. Inspect refrigerant charge in the outdoor unit. C. Adjust thermostat deadband for all zones. D. Increase fan speeds in each indoor unit. Answer. Correct answer, C. Explanation. Simultaneous heating and cooling wastes energy and often results from improper control logic or miscoordinated zoning. Reviewing indoor unit control sequences ensures heat recovery is properly utilized. Adjusting thermostat deadband may temporarily reduce conflicts but does not correct underlying control issues. Refrigerant charge and fan speeds impact performance but do not resolve the core seek problem in RF systems. Question 24. Demonstrated by recent BAS data Lewis finds that several rooftop units operate below design airflow despite adequate fan speeds. What should she investigate to identify the root cause? A. Inspect ductwork for obstructions or pressure losses. B. Recalibrate thermostats in each zone. C. Increase refrigerant charge in the chiller. D. Adjust outdoor air damper positions. Answer. Correct answer, D. Explanation. Reduced airflow with proper fan operation often indicates duct obstructions, improper damper positioning, or pressure imbalances. Inspecting the duct system helps locate physical restrictions, while balancing dampers ensures design airflow reaches all zones. Thermostat recalibration or refrigerant adjustments do not correct airflow deficiencies. Outdoor air damper adjustments may affect system balance but must be coordinated with total airflow to avoid overventilation or inefficiency. Question 25. Through careful analysis of energy consumption, Mr. Evans notices frequent short cycling of a chiller in a medium-sized office. What strategy aligns best with energy-efficient design principles? A. Implement lead lag or staging controls to distribute load and minimize short cycling. B. Increase thermostat set points to reduce cooling demand. C. Inspect duct insulation for leaks. D. Adjust fan speeds to match chiller output. Answer. Correct answer. A. Explanation. Short cycling reduces chiller efficiency and accelerates wear. Lead lag or staging strategies rotate units or modulate capacity to maintain operation closer to optimal load, improving energy efficiency and system longevity. Adjusting thermostats or fan speeds may provide temporary relief but does not address the fundamental cause. Duct insulation affects distribution efficiency but is not the source of short cycling. Question 26. While examining the consequences of improper airflow distribution in a multi-zone building, Rivera observes high static pressure in the main duct branch. What should be her first corrective action? A. Check for blocked or improperly set dampers and rebalance airflow. B. Increase fan motor horsepower to overcome resistance. C. Adjust thermostat set points in affected zones. D. Replace all duct insulation. Answer. Correct answer. B. Explanation. High static pressure often arises from blocked dampers, undersized ducts, or design errors. Identifying and correcting these through inspection and balancing ensures proper airflow distribution. Simply increasing fan horsepower increases energy consumption and may cause noise and vibration without solving the root cause. Thermostat adjustments or insulation changes do not address airflow resistance. Proper balancing ensures energy efficiency and occupant comfort. Question 27. In an effort to improve indoor air quality, Istakim assesses a building where several zones report poor ventilation. The AHU has variable speed fans. What is the most appropriate step? A. Verify minimum airflow set points and valve box operation. B. Increase thermostat cooling set points. C. Inspect refrigerant levels in the chiller. D. Replace duct insulation to reduce leakage. Answer. Correct answer. C. Explanation. Poor ventilation often results from valve boxes not maintaining minimum airflow or misconfigured controls. Checking set points and terminal operation ensures adequate fresh air delivery per ASHRAE standards. Thermostat adjustments affect temperature but not ventilation. Refrigerant levels influence cooling efficiency, not ventilation directly, and duct insulation affects energy loss rather than minimum airflow compliance. Proper control and monitoring are critical for IAC. Question 20. During commissioning, Johnson finds that a building's ERV is recovering heat effectively, but moisture removal is insufficient. Which concept should guide her corrective action? A. Evaluate latent heat transfer efficiency and airflow balancing. B. Adjust zone thermostat set points. C. Inspect refrigerant charge in the air handler. D. Increase outdoor air intake to enhance ventilation. Answer. Correct answer. D. Explanation. ERVs transfer both sensible and latent energy. If moisture removal is insufficient, it often results from reduced latent heat exchange due to foul cause or improper airflow. Proper evaluation of latent performance and balancing airflow ensures both humidity control and energy efficiency. Thermostat adjustments, refrigerant charge, or increasing outdoor air alone cannot correct latent load deficiencies and exacerbate energy use. Question 29. Considering the evidence, Mr. Harrison observes that hydronic terminal units in a high-rise deliver inconsistent heating despite balanced pumps. What should he evaluate next? A. Inspect and adjust coil valve operation and flow control. B. Recalibrate thermostats. C. Increase pump speed. D. Replace duct insulation. Answer. Correct answer. A. Explanation. Terminal unit inconsistency often arises from partially closed or malfunctioning coil valves affecting flow to individual zones. Correcting valve operation restores design temperatures and ensures energy efficiency. Thermostat recalibration may improve comfort feedback but does not correct flow issues. Increasing pump speed can overpressurize circuits and waste energy. Duct insulation does not impact hydronic distribution, making valve inspection the primary corrective step. Question 30. To illustrate this point Lewis is reviewing data from a building with a system where several indoor units operate simultaneously in heating and cooling modes. What is the most energy-efficient resolution? A. Adjust the control sequences to properly utilize the RF heat recovery features. B. Increase the cooling capacity of the outdoor unit. C. Replace all indoor unit fans with higher speed models. D. Recalculate the building load to verify sizing. Answer. Correct answer. B. Explanation. ERF systems can transfer heat between zones to avoid simultaneous heating and cooling, enhancing efficiency. Adjusting control sequences to properly stage heat recovery prevents energy waste. Simply increasing cooling capacity does not resolve control conflicts and can exacerbate energy inefficiency. Replacing indoor fans or recalculating loads does not directly correct the sequencing issue, making proper optimization the primary solution.